In Lab 3, we're going to get a little bit more practice with descriptive statistical analyses using two basic procedures, one which you've already seen before, proc univariate, and another one, proc freq. The data we'll be working with are from a study conducted at Gradial Memorial Hospital in Atlanta. I'll let you read the description of the data in the lab notes. Basically, we have data on patients and multiple measurements taken on those patients while they were at the hospital. So let's go to the program for this lab and let's march through it step by step. I'll omit some of the steps because you're going to work through these same steps on your own during the lab session. Of course, you should have read the lab notes before you got to this recording. If you haven't, please stop the recording, read the lab notes, and work through them so that you're familiar with what's coming up. I'm going to go straight to the program, and I actually have already cut and pasted the program from page 2 into SAS. So let me switch to my SAS session, and here it is. And let me get rid of a couple of copy and paste errors that I put in here. Let's go ahead and take a look at the program. We begin with the header comment. No problem there. In step 1, we assign a library. The reason for this is that the data set, which is called Nilton, that is a permanent SAS data set, and it's saved in this folder on the S drive. And so we need to set up a library which refers to this folder. So study the lib name statement, and if you don't understand how that's constructed, please review the notes from the previous lab. Now in step 2, this is some work for you to do. I'm actually not going to do step 2. We want you to review lab 2 and to think about how you could examine the contents of the Nilton data set, which is in that BIOS500 library that we created in the previous statement. How would you examine the contents? And by examine contents, we mean run an appropriate procedure so that you can figure out how many observations there are, what the variable names there are, plus some other similar details. So I'm going to march right on ahead to, actually I need to run step 1 first, otherwise nothing's going to work. Give me a second here. There we go, run step 1, click on the running person. Always check your log window. So I'll go to the log window, and SAS tells me that the library was successfully assigned, so everything's working just fine so far. Alright, so step 2 is for you. Step 3, well, we have a number of variables in the data set. We've picked on one of them for this demo. It's called albumin, and it's a continuous variable. Okay, it's a continuous variable. And so how would you perform a descriptive analysis for a continuous variable? Well, you need to calculate means, standard deviations, and other statistics. You need to create perhaps a histogram. We've seen previously that proc univariate is one procedure that can do all of those things for you. So here's a call to proc univariate, and it should look quite familiar to you based on previous experience. We simply invoke the procedure by typing proc univariate, and then we tell proc univariate which data set to work with. So we type data equals, and then you type the name of the data set after data equals. Well, not just the name, you have to type the library in which the data set is contained, BIOS500. Then you type a period, and then the name of the data set, which is Nilton. Remember that BIOS500 library name, it's actually called a libref by SAS. That comes from the lib name statement at the very beginning of the code right here. Alright, let me go ahead and run this. Oh, of course there's a var statement in proc univariate where you name the variable for which you want means, standard deviations, and other statistics created. If I left off the var statement, proc univariate would look in the Nilton dataset and would give me proc univariate output for every numeric variable. And there are quite a few numeric variables in this dataset, so I'd get a ton of output. So it's a good idea to put the var statement in to specify the variables of particular interest at this point. Alright, I'm going to go ahead and run this. Now I know this code is not new for you, you've done this kind of thing before, but we will spend a good bit more time looking through the proc univariate output in this particular demo. So pay attention once we get the output. I'm going to go ahead and run this. I know I see output on the screen. It's always a good idea to go ahead and check the log window and make sure that there weren't any warnings. And all I see is a note saying proc univariate ran and used up a certain amount of time, so no warnings, no errors. Come back to the output window, and let me scroll up now, and let's march through this output bit by bit and try to point to each number, well, not every single number, but as many numbers as we can, and say something about them. First of all, n, that's the sample size. So there were 377 observations in which albumin was recorded. We have albumin levels for 377 patients. Then right underneath that is the mean albumin level, 2.84 if I round to 2 decimal places. Notice the SAS gives you tons of decimal places. Of course, when you report any of these statistics, you've got to report an appropriate number of decimal places, and the what is it, 8 or 9 that SAS gives you here, that's not an appropriate number. It's got to be cut down to maybe 1 or 2 decimal places, quite often 1. Sometimes you need that second decimal place. It just depends on the particular measure and the way people traditionally report it. The standard deviation is right underneath that, so let me see if I can highlight just the standard deviation. That's nothing new. And then we have a statistic that does look new. I haven't talked about this one before. It's the skewness statistic, and it's 0.23. Well, the skewness statistic is a numerical measure of the degree to which the data for albumin, in this case, are skewed. And here's how it works. If the skewness statistic is 0 or pretty close to it, well, then the data are pretty symmetric. If you drew a histogram of albumin levels and the skewness value was 0, well, then the histogram would be a perfectly symmetric picture.